Previously we talked about charging with friction. Now we're going to talk about charging by induction and what that means. Induction charging is the way to charge without touching. So with friction, remember we had to rub two surfaces, the balloon and our head, against each other. And we rub those two surfaces. One would become negative, one would become positive based on electron affinity. Induction charging is without touching. So without actually touching is what induction is. We're inducing a charge. So here's an example of how to induce this. You have two spheres and they're mounted on insulating stands. So these stands are probably made out of styrofoam or something that will not conduct electricity. We take our balloon, we rub it on some rabbit fur and make it negative. Then we put it next to these spheres. Now when that happens, this is where polarization occurs. And if you remember from polarization, this negative charge on the balloon pushes the negative charges on the spheres back this way. When that happens, this sphere has all the positive charge. This sphere collects a lot of the negative charge. As long as we keep this balloon here and pull sphere B away, as long as they're not touching anymore, the negative charge stays with sphere B and the positive charge stays with sphere A. Since these objects are metals, and metals are being good conductors, the charge will then spread itself out, and what we'll have is A will go from neutral to positive, and B will go from neutral to negative. So we have expansion charge without touching anything. This balloon does not touch any of these objects in the case of induction charging. So, law of conservation of charge. The overall charge in the two spheres, the first sphere after is positive 1,000, and the second sphere becomes negative 1,000. But in the end, our overall charge stays neutral. So proving the law of conservation of charge still exists. Okay, so look in the same way. Let's take a positively charged object. So we take a balloon and we make it positively charged. We rub it on something above it in the triboelectric series, and it can be cellulose or something like that. And then what will happen is the positive charge gets close, it will attract the negative electrons this way, while the positive charge gets pushed away due to repulsion. Again, as long as we keep that balloon there and we pull apart these spheres, sphere V will keep the positive charge, sphere A will become negative, and that's what we see as the metals start to take the conductor starts to take the charge and spread it out, and we have a negative charged sphere and a positive charged sphere. And again, this is induction. We are not touching. This balloon is not touching at all during this whole process. Do this with pop cans. Take a styrofoam cup, take a couple of aluminum pop cans and put them on there and make them touch. Take a balloon, rub your hair on it, and just hold it again, not touching the pop cans, and leave it there for a while. And what you do is you will induce charge. The negative charge will go away and a positive charge will come forward. And what will happen then is what we'll see is if you keep the balloon there while pulling this can away, this can will take a negative charge and this can will take a positive charge. But the overall charge stays consistent. And we can use that charge then to do other things. Now, what is grounding? We'll talk about what a ground is when we get into defining what a ground is. But a ground is just what we would call something that gives or accepts electrons. It's a reservoir of electrons. So either it gives or takes away electrons. So here's how we can charge a single sphere by induction. Again, neutral charged sphere. We take a negative charge. Now this polarization occurs. Half the sphere is negative, half is positive. So we get a positive end and a negative end due to polarization. Now you touch this with your finger, and you are a good ground if you're touching something. And all the electrons, because they want to get away from this, will go right into your hand to leave that sphere. Move your hand away while leaving the balloon there. As long as the balloon stays there, then what you'll have is all the electrons will leave that can leave. And after you pull your hand away, this will have a positive charge. Given a chance to distribute itself, the charge will be positive. So, using a ground, you can charge a single sphere. Take some practice to do it right, but the key is leaving your balloon there while you're moving all the electrons. So, ground by definition is a large object that's an infinite source of electrons, or sink for electrons, or a reservoir for electrons, whatever term you want to read from your text. But that's what that means. So, charging a single sphere by induction again. Now we're talking about a positive charge. So, neutral, positive balloon, polarizes the sphere. We stick our ground up there. Now, because this is positive charged, the electrons aren't going to go in, they're going to come out of the reservoir, the ground, U, into the sphere. So the sphere is going to collect more electrons because of this positive balloon. Pull your hand away, leaving the balloon. This balloon then will keep a negative charge all over here, and then once you pull the balloon away, distribution occurs, and you see electrons added. And this will cause more. Now, one thing to make sure you understand, don't think this happens. The positive charge doesn't leave through the ground. The negative charge, more negative charge, enters through the ground. Remember, a ground, infinite source of electrons. So, here's some things to understand about induction, and this is difficult, so please pay attention. 1, the charged object is never touched. There's no touching in induction. 2, there's no transfer of electrons from the charged object. So the balloon in our previous examples is not moving electrons. They're not going into the balloon or out of the balloon. The balloon is not transferring electrons. 3, the charged object serves to polarize the object being charged. It just polarizes. It just redistributes the charge. If the balloon's negative, then all the positive charges on our sphere and negative charges separate, like repel, opposites attract. 4, the object being charged is touched by a ground. Electrons are transferred between the ground and the object. So if we touch this with the ground, ground, then the electrons are either going to go away, in this case they will, or if we're talking about opposite charge, our balloon positive, and we touch it with the ground, then electrons enter. But electrons will enter or leave through the ground, electrons only. And then lastly, the object being charged ultimately we see a charge that is opposite that of the object used to polarize it. And that's important. If I'm polarizing with a negative charge, in the end this object will have a positive charge. If I'm using a positive charge to polarize, in the end our object will end up with a negative charge. Sorry about that. I hope I didn't miss anything. And I think I'm good. Thank you.